students, and welcome to Lesson 2. In this lesson, we will be focusing on estimating real numbers. We will specifically be looking at square roots. In today's lesson, we have 3 essential questions. The first is, what are square roots? This question has already been addressed in the previous lesson, but we'll build upon that foundation. Our second question is, how do I find the value of a perfect square root? How do I find exactly what it equals, in other words? And last, how do I estimate the value of a non-perfect square root? We do need to estimate the value since it is an irrational number and does not terminate. So what are square roots? Simple, right? Roots that are square. Just kidding. A square root of a number is another number that can be multiplied by itself to equal the original number. For instance, the square root of 9 is 3 because when 3 is multiplied by itself, the result is 9. When finding square roots, you should think what number times itself is and whatever number is inside the radical. In other words, what number times itself is 9? 3. 3 times itself is 9, and you can restate it backwards to make sure it makes sense. Here are the square roots that you need to know off the top of your head. You saw something like this in the last lesson. You do need to memorize the first 12 perfect square roots or be able to generate them. 1 times 1 is 1, so the square root of 1 is 1. 2 times 2 is 4, so the square root of 4 is 2, and so on. These 12 are the first perfect squares. Now, perfect square roots are rational numbers, and non-perfect square roots are irrational numbers. We learned about this last time. For example, the square root of 16 is a perfect square root, and it's rational because it's equal to the number 4. The square root of 25 is also rational because it is equal to the number 5. 5 times 5 results in 25. An example of an irrational square root would be the square root of 20. The square root of 20 is somewhere between these 2 perfect square roots. The square root of 16 was 4. The square root of 25 is 5. So the square root of 20 is somewhere in the middle, 4 point something. In this lesson, we're going to learn how to estimate what number would come next, which in this case would be approximately 5, 4.5. But we'll learn exactly how to estimate that. So here are our goals for today. Our first goal is to be able to state the integer equivalent to a rational square root. For example, we just did an example like this when we said the square root of 16 is 4. We stated the integer, 4 is the integer, that's equivalent to this rational square root. Our second goal is to be able to estimate to the nearest tenth, which is 1 decimal place, the equivalent to an irrational square root. So for instance, when we said that the square root of 20 was about 4.5, we were estimating because it's not exactly 4.5, but it's close to that. And when we estimate, we can use this symbol to show that it's an estimation, about 4.5. Our first goal is the easiest because it is equal to a whole number. So when we read this, we can say the square root of 16. What number multiplied by itself is 16? Well, you know that that is equal to 4. 4 times 4 is exactly 16. This is a perfect square root, a rational one. Let's look at a second example. The square root of 121. What number multiplied by itself is equal to 121? This is a rational square root and it perfectly equals 11. 11 times 11 is 121. What about the square root of 1? What number multiplied by itself is 1? This is also a perfect square root, so it's equal to 1. 1 times 1 is 1. Now, let's look at how we estimate non-perfect square roots. In this case, we have the square root of 30. Think about our clock. Between what two perfect square roots would the square root of 30 lie? It would be between the square root of 25, which is 5, and the square root of 36, which is 6. So we know that 30 is 5 point something. Now, we know that a decimal can be created by a fraction. So we know that we could write a fraction instead of a decimal, and that's what we're going to do. Think about the distance between the square root of 25 and the square root of 36 as the whole way between these two perfect square roots. How much space, how many square roots are between the square root of 25 and the square root of 36? There's 11. How much is between 25 and 30? 5. So the square root of 30 is 5/11 of the way to the square root of 36. It has 5 more than 25, but it would need 11 more to get to 36. 5/11 is a fraction that's very close to half, 5/10. We can prove it using division. The top number goes inside our divide box. We're going to add 2 decimal places just so we can see how it rounds. And we're going to divide it by 11. 11 will go into 50 4 times, which is 44. There's 6 left over. Bring down the 0. 11 will go into 60 5 times, which is 55. There's 5 left over. But this gives us enough to round to the nearest tenth because we can look to the right, decide that the 4 rounds up to a 5, so this is about 5.5. We can say that the square root of 30 has an approximate value of about 5.5. Now it's not exactly 5.5 because this is an irrational square root. Its decimal never stops. So this is the estimate of what the square root of 30 would equal. Let's try another example. The square root of 150. Well, you know that your perfect square root list only goes up to the square root of 144, which is 12. What perfect square root would be after that? The square root of what is 13? Those of you who know your multiplication facts well know that it's 169. Otherwise, you would need to do 13 times 13 on the side of your paper. So that means that 150 must be 12 point something. We're going to write a fraction. How many more is 150 than 144? It's 6 more. How many more would it need to get to 169? 25. So we would say that the square root of 150 is about 12 and 6/25. because it has 6 more than the square root of 144, but it would need 25 more. Now, if we pull up our calculator for time's sake, we can see that 6/25, 6 divided by 25, is equal to 0.24. So the square root of 150 is about 6.24. Now that's rounded to the nearest hundredths. We want to round to the nearest tenth. So look to the right. Here's the tenths. Look to the right. Keeps it of 2 because it's less than 5. So the square root of 150 is about 6.2. Let's do one more example together. The square root of 91. If you look at your perfect square root, clock, you would see that the square root of 91 is between the square root of 81, which is 9, and the square root of 100, which is 10. That means that the square root of 91 is between 9 and 10. It's 9 point something, or 9 and a fraction. How many more is the square root of 91 than the square root of 81? It's 10 more. And how many more would it need to be to get to 100? It would need to be 19 more. So we could say that the square root of 91 is about 9 and 10 out of 19. I know that 10/20 is a half, so this is about 9.5 or 9.5. If you used your calculator, you would see that it would round to 9.5. 10 divided by 19 equals 0.52, and the 2 would keep the 5 the same, 9.5. In your practice problems tonight, you have 2 perfect square roots. I just want to point out that these 2 are perfect, and 2 non-perfect square roots. Try them, and you'll be able to discuss them with your team tomorrow. Let's look at a real-world application. Let's say that you want to install a square skylight. Now you know a square has 4 sides that are all the same, and it has an area of 130 square inches. If you want to figure out how much a side is, you can square root the area and it'll tell you the side length. The square root of 130 is between what 2 perfect square roots? 121, which is 11, and 144, which is 12. So we know that 130 is going to be 11 plus some extra. How many more than 121 is 130? 9. And how many more would it need to be to get to 144? 23. 9/23 is equal to 0.39 or 0.4. So this is about 11.4 inches on each side. If we wanted to calculate the length of each side, we could do that in this way, finding the distance that one side would be. If we wanted to know the length of trim to go the whole way around, we would have to multiply that by 4 to get the total distance since there's 4 sides. And we would get 45.6 inches. We would need 45.6 inches of trim to go around the skylight.